I'll just do the monitor off. Okay, well, monitor off. Monitor output, monitor only. Okay. Okay, that seems good. Now I don't go crazy listening to my own audio. So we have audio working. That's great. So welcome to another video. We're going to look at a Xilinx ZYNQ FPGA that I was able to find on eBay. That I when it originally came out, I was really excited for it. I do have to say I'm sorry for the slight hiatus. Was it like a month and a half? I hope to get back to doing reoccurring videos, and I'll start posting the schedule on YouTube that people can pay attention to if they care. So today we're going to talk about the Snickerdoodle. It's a kind of a Wi-Fi enabled ZYNQ device. As it stands alone, I don't really think there's anything crazy about it except the Wi-Fi feature. But yeah, let's go ahead and kind of walk through the block diagram over here for what is available on just these boards alone. So go over here. We have the main player here. We have a Xilinx ZYNQ, and there's 6 different variations you can acquire. We have 2 Snickerdoodle Blacks and 1 Snickerdoodle 1. Snickerdoodle Blacks are probably the best ones. They're 720 speed grade 3. A lot of nice features on those boards. We got 2 of those boards. And the Snickerdoodle 1, same FPGA, lower speed grade, and I don't think it has, and it doesn't have the Bluetooth portion, the Bluetooth module available. So, I mean, if we look at this block diagram, it's fairly simple. We have the ZYNQ, we have a bunch of these I/O expanders on the board, and then we have the Bluetooth and a microcontroller that's just kind of enabling the boot up process, doing some firmware, changing the boot modes, so you can do different configurations, and that's basically it. So we have some very basic components here. So let's talk about my journey of getting it what I expected. So let's go through and we're going to walk through what they advertise on their page here, right? So we have the Snickerdoodle. You can get in a box. You can. Bunch of cool parts, advertising some articles. Oh, I wanted to go to the crowd supply page. That's where the fun information is. So let's go find the crowd supply page real quick. So we do Snickerdoodle FPGA. Let's go to the crowd supply page. That actually has the most information here. So the crowd supply page. Why do I need a Snickerdoodle? They say it's low cost, powerful. You can do some cool things with it. I won't argue about that, but this enables another platform. It's not a very good standalone device, right? You connect to Wi-Fi and you can do cool, maybe over Wi-Fi updating, monitoring, maybe something that you can like I2C devices, SPI devices. You could connect them, have some like mobile Wi-Fi wireless sensors. You could use it as a kind of a logic analyzer, a Wi-Fi capable logical analyzer, which is cool in itself. Apparently the Bluetooth, I have not tried a Bluetooth. I haven't really seen any instructions for that. I've done this IDE, so that looks like just an Eclipse-based one. We have a YouTube channel. Go check that out. We should go review a YouTube channel during our YouTube channel. Who needs wires? That's what they're talking about. Off the grid, basic connectors. So the JTAG is located here in J2, and we'll talk a little bit more about JTAG because that's when I do FPGA development, I want access to the JTAG. If all else fails, I want easy access to the JTAG. So I do like these connectors. They're pretty solid connectors. I bought a bunch of the little things you can connect to it. So we'll see what we can connect to JTAG before the night's over. That's what we looked at. Oh, do we have 1 gig on ours? We probably have 1 gig on ours. devices, ZYNQ books. So if we go down to JTAG, right, they have some breakout boards, which are cool but expensive. Like this breakout board was $250, and I'm not sure if I can just the breakout board's $250. I mean, it's cool, but man, it's a little bit out of my wanting to buy for fun price range. So let's go down to where it talks about JTAG. Let's just JTAG is. Okay, down here, I don't see JTAG in the board. Well, a couple places actually. For starters, okay, that's what we're going to go today. Secondly, you can actually debug over Wi-Fi via the debug agent in Linux. I don't know what they mean by the debug agent. That's not. Maybe the idea is when you have Linux running, you can actually develop in the Linux app thing. You can do the FPGA. You can test different things. But I still want access to JTAG if I want to do embedded platforms. Not use the software, just FPGA. I want JTAG. You can also get JTAG over micro USB facilitated by this note due to so this feature, they talk about this micro USB feature over JTAG. This currently does not work. They say so in their forums. This does not work. And the breakboard has standard JTAG headers, which I don't have. I guess I could have got that one, but I didn't feel like it. So we have a bunch of wires, a bunch of connectors, and we can figure out how to get JTAG later. But yeah, I think that's it for the JTAG. So let's talk about how I got this up and running. So they have a bunch of kind of tutorials and guides, and I didn't have an SD card to start with, so I had to go play around with this. So let's talk about what I had to do first. So the very first thing I had to do is I had to update the firmware. So let's talk. So this is the firmware running on the microprocessor. So let's talk about what's running on this microprocessor. We changed the boot mode. We can change the antenna selection, LED override. Not sure where we're actually running these commands from. This is a SPI control. A low power mode. Interesting. So I went through this process. I used the Windows instructions and I used the Linux Mac instructions to update my firmware. It's fairly straightforward, easy to do. This one was a little hard. It's missing a button. I got a replacement button. I'll fix that later. But these two were easy to update the firmware. So first thing you have to do, follow these instructions, download the firmware and SPI controller. And if you go to their where do they keep their? They have a GitHub page for all this stuff. GitHub. I guess it might be no. Go to Snickerdoodle and go to the bottom again. This stuff's a little bit hard to find. It's like in 20 different places, and you got some on GitHub. You got some here. You got some on a wiki. You got forum pages and stuff like that. It's kind of all over the place, so it's a little bit hard to find the information you need. The manual has some cool stuff. We'll go through the Wi-Fi manual later. But right, they have opened the schematics as well. We'll look at that in a second. We have the firmware right here, and the board files are useful. The firmware, it's been a while since it's been updated, and you can go through and look at it and check out. They don't have an official release, so I guess you just have to use their download page for official releases. So we've updated the firmware. So that was the first step. The next step, they have these two pink images, or two Linux images. So the Ubuntu image, that works for all the Snickerdoodle devices. The pink only works for the Snickerdoodle Black, which will run on this guy. You probably could easily update it to the other ones. I did find some useful instructions online how to do that, but I'll figure out how to do that. I do want to update this to a newer version of Pink using a new version of Pavado and Linux tools and FPGA Manager. Play around with that. Maybe get Vitus AI to run on it. Some interesting stuff we could try. But that's going to require some work. But I've tested both these images on these boards and they both work fine. Following the instructions are useful to get username, Wi-Fi, and other things working. But we'll show that. So right now. So we're gonna take this SD card out, and I am going to re-image it with the pink image, and we're gonna run that on the Snickerdoodle Black. I may run it on my. Oh, I not have. let's show you how I love to image things. So this is my favorite way to image something. So we're going to downloads Snickerdoodle pink, grab that image. We're going to select the target of the 16 gigs, and we're going to flash. This one's going to take a bit of time, but it should be fairly straightforward. And we'll let that run. So while that's running, we're going to try to get the JTAG to work on these boards. The way we're going to do that is we're going to go check out the schematics. So we're going to go open source schematics. They don't have a BOM file. I wish they really had BOM files so you can see what parts there are reordered. I had to hunt down the buttons to make sure I got the right buttons they were using. Unfortunately, I already had another board that had a broken button that was using the exact same parts, so it was actually easy to find. So what we want to do is J2. We want to get J2 working. This one that's not. It's not the most useful diagram. They have a better diagram down here. Oh, why we're here? There is potential to use the USB and Bluetooth to do JTAG. They just don't have those features enabled. But maybe I'll look at doing some driver software for this so we can rewrite how the JTAG works. That would be interesting. Maybe do some interesting JTAG functionality, maybe a warm boot or something. It'd be fun to write some software here, so hopefully I don't screw it up, but hopefully we can write some software. So we're going to go down to the connector picture, which is like all the way here. So we're going to go to J2. So J2 is right here. And let's see, if we look at these boards, right? Okay, we see the square here. There's a square. You can't really, can you? Ah, not good at this. Oh, focus. Let me see. Focus. Focus on this guy. Focus. 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 Okay, there's a little square. You can't even see it. Whatever. The top right one is the 0 pin, right? Yeah. So that top left one, right there is the 0 pin. So the 0 pin, or the 1 pin, is right here. So when we flip this over, that's going to be on the bottom. Is there a good way to see that? Well, there's also a white dot right here symbolizing the 0 pin. So what we want is we want TDI, TDO, T-clock, TMS, VCC, and ground. VCCO is the 3.3 ground we probably want. Let's look at what is P ground. What is the difference between P ground and ground? So can I look at this slide? I can't. So download this, I guess. We have another schematic. That's okay. What is P ground? Power ground. Power ground looks like the right one we want to do. So what we're going to do for this guy, right? We're going to take him and we're going to stick this connector in. Oh, they're actually labeled on the connector. That's really useful. Feel like a solid click. Does this just sit in here? Seems so weird. Let me try another one of these connectors. It doesn't sit into it. That's so weird. Ugh. So we got a big connector here. Oh, that's the wrong ones. Here we go. Do these just sit in, or do they actually like clamp in? I don't see any like clamps. Yeah, these connectors, they'll fall out. They're a way to what these things don't really wedge in. They're just okay, cool. We have that there. So let's go back down to where we were looking. Do do do. Okay, so using this wonderful diagram here, we want to get these 6 pins. So we're going to take this black one. Hopefully we can do this without crimping or putting anything in. And this is going to go on 26. 26 is going to be the bottom row. Yeah, I'm not doing this on camera, guys. It's hard enough to see by myself. 26. Yeah. Yeah. Oh, that's probably how it gets in there better. Okay. So, next we're going to use the red line for VCC. What do we want to do? Let's do green will be clock. So we'll do green for T clock. And that is going to be 21. Okay. Yellow, we'll do TMS. Okay. Blue will be TDI. And our off red or purple right next to the black will be okay. See, do the pins help it stay in? A little bit better. Okay. Next, we're gonna connect it to this guy. So my colors don't match very well. VCC is the blue one here, so we're gonna do blue to red because I didn't feel like organizing colors. Next, the green is ground, so we're gonna do that to the black. So T clock, which is our yellow one here. Terrible. Oh, you can't even see what I'm doing. My hand's in the way. Sorry. We're gonna do yellow to green. Guys, I did this the best way possible. It looks like, sounds like our thing finished. TDO is the purple, which is going to be orange. This one. I just want to connect the JTAG. This is all just for JTAG. Yellow is TMS, which is going to be the brown. And our red, which is TDI, is going to be the blue. Hopefully this works, and our pins, I don't think change. Okay, so we have JTAG working. We need to power it. Wait. Yeah, we have a good long cable to power it. Take this one. Okay, so I'm gonna show you the pink card. What I need to do for the pink card real quick. So let me unplug and plug it back in real quick. Okay. So for the pink card right here, we have a config file which talks about the users, but pink is Xilinx, so I like the password right now. So we're just gonna grab these two things, the boot bin and the image UB, and we're gonna stick them here. And our pink image is now good to go, and we can eject it. So we'll show you that in a second. And I might have to connect it to my other machine so we can actually look at it. Okay, so let's first power the board over USB. Okay. And it looks like it's all the virtual machine. And the even's going to be on top. Okay, I think we're good. We're going to plug this in. Hopefully it doesn't ground or short or anything. Let's make sure blue goes to red one over there, and the black one goes to the green. Okay, I think we're good. Let's see if we can do, let's see if I got the FPGA I'm supposed to be. I'm supposed to get a speed grade 3 here. Okay, so what we're going to do is we're going to open up the tickle script for tickle shell for Vivado. Do this. Let's figure out if we can read JTAG. Otherwise, I'm going to be very sad. We could try to boot in JTAG mode and see if that changes anything. It shouldn't. We should be able to look at JTAG anytime we want to. So we're going to hit connect to get to our local JTAG server. Hit JTAG targets. JTAG targets. USB may be bad. Okay. 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 I mean, it's connected, right? Okay, let's boot this thing in JTAG mode. So to boot it in JTAG mode, we're going to hold these two things. No, we're hold select. We're gonna hold select until that, and both light. No, sorry. Hold select while we do this, and we get two lights, and both lights are JTAG mode. And then we power cycle. I should okay. Okay, we're gonna disconnect this guy. See if this is an issue with this USB. Okay. I just may have a bad USB. You might have to give me a second while I go hunt down a good one. Okay. We'll leave that one for that. Let's see if this one will power this reliably. Okay, yeah, these are just garbage USBs. Give me a second. I'm gonna hunt down a good one. white one. Hopefully better. Maybe it's our PC tower. Okay, that one seems good. Oh. Okay. Woo! Hallelujah. Okay, we have JTAG working, which is great. I'm so happy we got JTAG working. And hello, people, comments. We have Junior. I saw your chat a while ago. I'm sorry I didn't respond earlier. And we have a name I don't know how to pronounce. Ra. Okay, so we got JTAG working. We can't tell the speed grade from this, can we? I don't think we can. I don't think the speed grade is listed in the ID code. We look it up. But there you go. We have the device. So let's go ahead and try the pink image now. It may happen. I'm going to change back things. So we have JTAG. Usually when you're running Linux on these things, you don't want to get JTAG working. Cool. So let's go ahead and put this back in SD card mode. So, ow. Sorry, everyone who heard me punching my mic. So let's go ahead and put this. Try that again. It's in JTAG mode. I pushed the wrong button. Ugh. You want to hit select until there's just the bottom light. That is SD card. Okay, now we're going to take our pink SD card and see if this boots up properly. I may have to go put this on the Linux machine. It's also really hard for me to put these cards in. I always fail. Like that. Okay. There we go. So we're going to hook it up. And let's see if TerraTerm works. Serial port. Serial port. Okay, yeah, so let me go connect this to the Linux machine real quick, and we can show you Wi-Fi capabilities. Okay. We're gonna SSH into my machine now, so we can see the Linux side. Okay, so let's do this. Let's get Wi-Fi working on this guy. So we're gonna go into this guy. So what we're gonna cd into /dev. We can hide that for now. I don't need that. And if we do a dmessage tail, we can see that TTY AC0 was what was connected. So we're just going to screen that. Don't have to worry about the baud rate. It should handle that pretty well. Okay, now we're just going to boot. So this should boot Linux. Yay, we're booting Linux on it. It's great. It's great. It's great. Let's put that to half the screen, right? And what we're going to do for the other half of the screen is we're going to pull up the manuals. And go and look at the Wi-Fi manual. Pretty sure I have this in my downloads, but we can just go to the manuals. Manual! You don't have to log in. It's wonderful. It's beautiful. So, you know, these things have not been updated. It looks like the project has kind of not have gone under any good development in the past year. So we're going to go to wireless. These are the instructions. They have a nice LaTeX or PDF document you can look at. So let me show you how I get it up and running. I don't really follow their instructions. They use the WAPL and they have all these fancy little commands. But what I like to do is I like to go sudo underscore CLI, right? So this gives us nice, and for pink it's Xilinx. So we're going to do a scan, right? We're going to scan. Oh, actually we need to change the interface. So if we do interfaces, interface, there's two, right? So we're going to do the WLAN 0 like they do in their instructions. Now if we do a scan, and give it a second. There we go. And we do what? Scan results, right? We have all my fun little NASA Lehigh things. So let's just connect. We want to connect to NASA Lehigh. The other ones The other ones don't really work too well. We're gonna add a network. And it's network 0. So we're gonna set network 0 SSID to NASA high. Right. Then we're gonna set the PSK. I'm not gonna tell you guys what my PSK is for my Wi-Fi. You can know the SSID. I don't really care, but you probably need more to get into here. But that's all you're getting from me. And then we'll show you that right there, right? So now we're going to enable network 0. Yay! Oh, apparently I cannot type. Well, I mean, I knew that. So we're going to enable. Okay. And then we do status. Still finding it, right? Status. And now we're connected. Status. And now I just hit exit. I think. Wait. Right. And I think it's just DHCP or DH client WLAN 0. Okay. Let me make sure there's nothing special on this. Okay, we're good. So now we're gonna sudo bang that command. We're gonna DHCP client. I did not type Xilinx correctly, guys. Ask again. I have too many cables around right now. Okay, and then we do if config, right? We're looking at WLAN 0. Okay, so now we have wireless internet working, right? So let's go here and go 192.168.0.28. Nope. Someone did not have numlock on 192.168 0.28 9090. There you go, guys. We now have Pink, a Python-based FPGA interface, working on our common. Does this overlay even work? Or have they updated this overlay? Let's see if this works. There is no overlay loaded after boot. We got to. We need to add a bit file. That's okay. Okay, so we can do just like any other Pink environment. We can add a bit file. We can get running. We can do fun little stuff, and we got these Jupyter Notebook pages to work. But this Jupyter Notebook page is running on my ZYNQ processor. So yay! We have Wi-Fi notebook stuff working on the other one of this. So the last thing to do is let's go and try to get the board files working and try to get a simple block diagram set up. And I think we can call that a night. So right here, right? Go back to this guy. Let's open it all the way. The board files. So the board files are very useful. We have the Snickerdoodle black. So what we're going to do is we're just going to say, let's download this whole zip. Own folder. We're going to extract this with 7-zip. That's the funnest way to do this. And we're going to take Snickerdoodle black, and we're going to show you the best the place where we go and put these. So we're going to go to my PC. We're going to go to my wonderful C drive. We're going to go to Xilinx, Vivado 2019.1. Data boards, board files. Boom. And now we have a Snickerdoodle black. Should support this. Okay, so now we're just going to open up Vivado 2019.1 and show you what the board file for this board looks like. It may be simple, it may not. We're going to find out. Okay, let's go over. We're going to create a project. This project's going to be in stream. It's going to be what? Snick. Boom. Okay. We don't need to specify sources. We go to our board files, and right here we have the Snickerdoodle black. We're gonna grab this guy. Oh, I don't need to read it. I just want it. Okay, hit next. We have a speed grade 3. Beautiful, beautiful. And we're gonna create a quick block diagram. Maybe configure it real quick and try to upload it. I don't think we're uploading anything to the peak right now. So let's create block diagram. Sure. And let's see what the block diagram provides. It's going to provide the processor configuration, which will be useful. So we go to board. Is that all? They don't. Okay. So I guess the only thing they're providing here, they don't even provide the connectors to pin out. That's kind of disappointing. So we type in this. We should do MPSOC. Right here, ZYNQ 7 processor. I'm sorry, I've been doing a lot of MPSOC recently. I don't know what the normal ZYNQ one is. So we run block automation. There should be a board preset. Apply board preset, right? That's all we kind of want in this situation is the board preset. And I know what the fixed IR. Okay, sure. GPIO. And so this is configured correctly, and I'm so used to the MPSOC, this bothers me slightly. Boom. Let's see what our DDR controller configuration is. Memory part configuration. Cool. So there we go. We could try to run software on it and run it. Is there anything useful we could do? I mean, we could try to do some software. I mean, benchmarking, I don't think would be useful per se. IO peripherals. We can read the SD card. There's 2 SD cards. Okay, let's go back to the schematic. Why are there 2 SD card connections? Why do I have 2 SD card connections on this guy? It's probably for the Raspberry Pi breakout board. So we have 40. So we're gonna look for MIO 40. So okay, MIO 40 is going straight to J6. So that's a J6. So this is like an external one on J6, but if we go to MIO 10, right? This is all the SD card. Oh yeah. We have a UART. It's going to MIO 50. So that is the ZYNQ on RX. Where is this going? That is going to that machine. Okay, that's cool. We could add another UART and do a UART over one of these connections. We have a SPI. Where's MIO 46 going? MIO 46. Yeah, that's interesting. So the PC SPI MISO. This is going to this guy. So I assume you can control the state machine from the ZYNQ, which is pretty cool. But yeah, let's see. We have CAN connections. I don't know how CAN differs from these other ones. Okay, for all the IO peripherals. We have the flash there. Okay, what about the high-speed connections? Where's my high-speed IO peripherals? GPIO. Oh, we do have GPIO set up. There's a bunch of these GPIO, USB reset, and I2C reset. Okay, where are my high-speed connections? Peripheral IO pin. Do we have no transceivers on here? We have to have a few transceivers, right? I don't know. Do we have any transceivers on this guy? I don't know this FPGA board. We might not have any transceivers. I'm not seeing any transceivers over here, guys. So I don't think we have a transceivers, and that's probably it for now. Oh, in advanced mode I can turn on, right? IO peripherals, flash. Yeah, that looks like it. Okay. Yeah, so I mean, from here we could build a few things, we could try a few things, but that looks like all that is of the moment. So yeah, we talked about JTAG. There's no JTAG. I updated the firmware. We got the pink image working. We checked the JTAG over the port. We got the brighter ports looking up. We have it working over the internet, and we can do things here. Sad they didn't add any stuff to their any cool Snickerdoodle black examples to this. Kind of sad. Nope, nope. Let's see. Are there any Snickerdoodle FPGA pink? I'll do black. Are there any pink examples? Let's include pink. Okay, cool. I think that's about it. Okay, so I think that's all for really showing off the Snickerdoodle FPGA. This was a cool board to find. I got 3 of them, went in with 2 friends to get the other 2. So I think we'll see if we come anything out of it. I want to update the state machine so we can do maybe JTAG over USB or try to do JTAG over Bluetooth. I did not see the phone app to do Bluetooth communications. I don't really see any Bluetooth supported in the firmware at the moment, so I don't think that's necessarily possible. Yeah, if you have one, let's maybe try to revive these devices a little bit. Well, thanks for watching. Hopefully this was interesting. Join us later. I hope to do some additional videos on the advent code. It's a few months back, but I would love to do advent code back in HLS. Maybe some Vitus AI stuff. The Vitus AI stuff, I'm just not. I haven't seen really good application, a demo for that. We can do some crypto mining. We can have my FPGA chip. I have RTX Ultra Scale Plus coming into play. I'll make some. I'll schedule a few things and we can see how it works out.